So recently we finished our latest TiXL project called Ashborn. It was a tough ride with a lot of lessons learned and a great opportunity to better test TiXL's new shader graph system. Along the way, I made countless small improvements to the user interface, added tons of new features, and yes, I completely changed my mind on using variables in the graph. In this video, I will walk you through my creative process and explain in detail how the project and the effects work. I will also talk quite a lot about my tricks to deal with procrastination. If you like piano music, particles and animation, this one is for you. You can watch the capture of the fine animation linked below. Feel free to pause here and take some time to watch it first. Everything started with this wonderful soundtrack made by Lucid. It's a fragment of a piano improvisation, and I fell in love with that track. I close my eyes and I immediately see images. That's always a good sign. It's only an audio capture. There are no MIDI notes, no tracks, no velocity, nothing. And of course, there is no BPM rate. To get into the mood, I started by setting manual keyframes. My original idea was to capture how the time is stretched over the pacing of the song. So I would have one continuous curve I could then use for animation. Long story short, I completely failed doing this and aborted the attempt after an hour or so. The next attempt was to use audio reaction. And just testing this with a passing blob was once again a total failure. Just wasn't precise enough, and I wanted the playback to be reproducible. So, finally, I decided to bite the bullet and set keyframes for every single note. It's actually not as bad as it sounds. Create a value operator, animate it, connect it to a modulo, link it to the radius of a blob, press play, and keep pressing Shift-C to insert keyframes with increment, while the music is pausing in the background. A good trick that I implemented years ago but almost forgot about was to press Shift-L to halve the playback speed, and halve it again if necessary. Every time you need to insert or remove keyframes, you have to recompute the values. I noticed a couple of glitches in the dope sheet editor and spent some time procrastinating. And yes, in this project, I spent more time adding features and fixing bugs than actually creating content. My brain has a very hard time making any sort of creative decision and immediately jumps on every opportunity to get distracted. One of the things that bothered me was how difficult it becomes to read the curve graph in the dope sheet because the values are normalized to the value range. I ended up with 400 something manually placed keyframes and stretched over the height of an animation parameter. This is practically invisible. So why not just use the visible keyframes to infer the scaling? How difficult can it be? Well, a couple of hours later, the curve scales nicely. The whole implementation is much more efficient and my brain has no more excuses to be creative. So, the hardest part for me is to find a story. I gave a talk on that topic a long time ago, and it's still one of my guiding principles. I need a story to make creative decisions. Others might call it a concept. I was fighting with this for a couple of weeks, listening to the track every day, and finally tried to make some headway by structuring the soundtrack into parts. I decided to use time clips for this. Normally, time clips are used to switch between scenes of a demo. But here, it sounded like a good idea to just annotate the audio track. But what's that? Well, there are no keyboard shortcuts to split and rename clips. The clips are not positioned correctly after splitting. Well, just another good opportunity to procrastinate again and clean up this feature. Of course, it needs to be done. Now, there's no other way, so some hours later, the clip editing is so much better that I don't have any more excuses to be creative. And suddenly I have an idea of a particle system sprouting from a seed, going through phases of development from green blooming to industrialization to demise and falling back into nuclear doom. Bang. That sounds like a good concept. It could even be tweaked into a cycle. So maybe I should build up some particle effects now. The initial idea is to have some guiding particle system that will follow a Purdon noise. On every node, we accelerate and switch the noise phase. I was surprised how well it worked. But hold on, says the procrastinating part of my brain. That motion would look so much cooler if the particles moved faster on the louder notes of the soundtrack. Why being creative when you can spend some time programming instead? I always wanted to have a procedural method for generating keyframes. So I quickly implemented a new keyframe recording operator. We have a trigger parameter for when to insert a keyframe and another parameter for the value. Now I can save the current audio volume every time a note is being played. Only some hours later, I actually had a keyframe track that I could pipe into my turbulence force. And lo and behold, it actually looks slightly better. Okay, I had an effect that worked for 20 seconds or so. Not too bad, but what now? No matter how long I looked at the screen, I was stuck. One trick I learned to fool my brain into making creative decisions is by switching to another medium. In this case, just sketching on paper. It doesn't matter how bad sketches are. You can't turn them into particle effects. So it's fine to toy around and play with these ideas. They don't need to be pretty, and you can't spend more than a couple of minutes on doing one. Then I remembered that there used to be an operator called Sketch that I wrote to draw the storyboard for Still There. That was some years ago, and of course it was no longer working and provided yet another great opportunity for procrastination. Yeah, so finally it was time to use my little Wacom bamboo tablet and sketch out a super rough setup. Suddenly I was in the flow and sketched scene after scene. With the onion skin tool enabled, it was fun to draft progressions. With the keyframes, I could listen to the track and shift the pacing around. It was the first time I saw a glimpse of hope that I could actually pull this off. I was so excited that I immediately jumped into outlining the scene and the camera animation. For this, I created some rough blocking to get a feeling for the proportions of the effect. Just some spheres on the ground and some cubes. Of course, I found plenty of opportunity to tweak some operators on the fly, like this grid plane in the background. But yeah, the timing could work. And with the time clips, I basically had my to-do list fleshed out. 2 weeks left. Next, I did some more experiments with particles, SDF and shader graphs, and slowly developed the idea that we can model geometry and scenes with signed distance fields and use them to drive particles. The initial tests looked surprisingly cool. I always liked the particle demos by Fairlight. Well, and I gave up a long time ago on fretting about effects that were invented 10 years ago. On the fly, I cleaned up most of the particle forces and the parameters for the particle system. I experimented with a jump random force operator to make the ribbons jump on nodes. It looked nice, but it didn't really fit into the mood. Maybe somebody else will make a cool demo with that. On the fly, I constantly improved render caching issues. Always a perfect opportunity for some tasty procrastination. The idea here is that everything that is not changing should not be recomputed every frame. For instance, the grain operator has an animation speed parameter which is great because connecting a time operator every time would be cumbersome. But now I wanted to have a static groin texture on my floor, which suddenly needed to be updated every frame. TiXL indicated this nicely. Well, and with grain, the solution was to add a new freeze mode to our time operator. When frozen, time no longer invalidates everything that depends on it, and the thing can be cached. It's a small improvement, but I was slowly getting nervous about performance. So things like this add up. I also added a new parameter to control the emit velocity of a particle system. This allowed me to randomize points before emitting and scattering slightly. I'm still not really happy with how they appear, but I didn't have time to work on that further. So it's now 5 days to evoke, and the panic was really bad now. So I decided to pick a random scene and start working on it. Why not use the final mushroom cloud? I actually tried to do this with vibe coding and ChatGPT. Create a force to twist particles around a torus. How hard could this be? Well, it turns out that faking this animation was actually much harder than doing the real thing, like the real physical simulation thing. And I was about to almost give up after a couple of hours when suddenly and magically it started to look like a mushroom cloud, which was great. So I got some motivation back, and well, maybe it was possible after all to do the demo with this. So I ended up with this toroidal vortex field, whatever, I don't know how you pronounce this, that twists particles into a torus-like shape. To get some more control over the forces, I decided to add a new category of fields. In addition to distances and colors, fields can now return a vector. And of course, these fields can be multiplied and transformed, etc. It's pretty powerful stuff, but I ended up using none of this in the final demo. So, another couple of days wasted. So I moved on to work on the ending. Building it was surprisingly fast. Create a grid, instance some spheres, and add some fake shadow. But what's that? The specular reflection of the PBR material looked off. And that's bad. That's actually like a real bug that nobody spotted before. And after some experimentation, I noticed that the view direction was not correctly applied to the specular component of the light. The fix was easy enough, but now draw mesh and array marshing field had different appearances. So now I had two options. Fix all PBR rendered objects or fix it later after the demo. So, obviously, procrastination time. I separated the complete PBR shader computation into a separate include file, so to align it between all shading things in TiXL. And we recently added a new suite of visual tests, so we could verify and test it that scenes look the same after such a change. And obviously I noticed that we didn't have tests for PBR rendering yet, and no time like the present. So it was painful, but after a couple of hours, everything looked nicely aligned. Obviously, a couple of hours I didn't have, With the beginning and the ending part now connected to node keyframes, I noticed that there were a lot of connections going all over the graph. And it was crazy, but instead of building more scenes, I started to refactor everything into variables. So we now have new variable types for Boolean, triggers, integers, and vectors. And with this, I could create a new section that basically sets up all variables for every frame in the beginning. And then they could use later for the scenes. And I was already thinking about releasing at another demo party a couple of months later. I finally got enough energy to actually work on this landscape scene I sketched earlier. And I looked into a couple of examples on Toy, and especially I found like this scene by Thor. And the concept actually didn't look that complicated, but I wasn't sure if this could actually be turned into a distance field operator for TiXL shader graph. But sometimes you get lucky, and the height map SDF turned out to work great and played nicely together with the SDF to color. So let's break down this little example. We start with a fractal noise, and we only need a single color channel. That's why it's red. We can now tweak the parameters, and the gain and the bias is great for tweaking the shapes of the mountain. So now we cut a valley through the mountain range using the sine form operator. I hadn't used this one for some years, and of course my procrastinating brain couldn't resist the opportunity to first optimize its caching behavior. Now we can use the ZSDF material to add some color. A plain SDF gives us the distance from the ground level. And we can add some noise to this distance and then convert the distance to map a color gradient onto the mountain range. We can combine our mountains with another plain SDF for some lakes. And I have to say, like, tweaking the landscape was surprisingly pleasant and fun. It was fun. And suddenly we could use this field to attract particles. The field volume force also applied the colors to the particles when they collide with the surface. And boom, an effect is born, and it was Thursday. 2 days to go. Yeah. So I took the rest of the day off to work on the demo exclusively. I started by animating the mountain scene, and things were slowly coming together. But while tweaking the camera animation, I noticed that there was a bug that would break the interpolation when looking around and adjusting the position with the middle mouse button. And this was super frustrating. It was 7 o'clock in the evening, and I got really tired. And even my procrastinating brain wasn't eager to fix that. I gave it a try anyway, and it worked. But yes, TiXL's camera system really needs a serious overhaul. After adding some filler content and tweaking it a bit more, I try another run through, and suddenly things are coming together. It's almost like in this book by Ed Catmull, Creativity Inc., where suddenly and miraculously a movie no longer sucks. And so suddenly I have motivation again, and I spent a couple of more hours tweaking, doing more run-throughs, identifying 3 most critical glitches, fix them, and repeat that cycle over and over again. So eventually it's 11 at night. I render out a preview version, sent it to friends for feedback, and called it a day. Next day, it's Friday, and we are taking the train to Cologne. Working on content on the train turns out to be impossible. So I spent some time fixing more UI glitches instead. The next day, I finally have enough energy to actually work on the middle section. And things must be going well because my procrastinating brain decides that 5 hours before the deadline is the perfect moment to tweak how TiXL's editor displays and handles content below the graph. And yeah, the notebook display is small and I have so many keyframes and animated tracks that, optimizing this layout was actually time well spent. And then it's release time and it runs in the competition and I'm actually surprised how well everything suddenly comes together on the big screen. So normally I can't stand watching my stuff on the big screen because all I see are the glitches and the details I didn't have time to fix. But this time even my procrastinating brain is finally at peace. So, wow, here's the complete project. This is the complete graph. Everything is built procedurally. There are no images or objects besides the font we are using. So, I will use the rest of the video to quickly run you through the project. It will be available, hopefully, as an example project with the next TiXL release. And then you can have a look at it on your own and play with it. And okay, so we start with the final output here. The title and credits should be excluded from the post-processing, so we add a small group and do this first. The group's color is animated, so we can actually fade out all the components at the end. The post-processing is nothing special. It's just screen space occlusion, some bloom and growing. Not even a color grade. Next comes our main camera with a small Perlin noise driving the rotation offset parameter. And this just adds some handheld camera shake. Tweaking the camera animation was super tedious and I was constantly scared that I would break, insert some invalid keyframe or something. So I constantly duplicate this operator as a backup so I can fall back into this. All keyframes are set to cubic interpolation. And there is this draw cam gizmos that lets you see the camera view in relation to the scene. It's a little bit awkward to set up, but to use it, you have to switch the output window's camera mode from auto to viewer. I also used the operator called gizmo visibility quite extensively. This will toggle elements if you toggle this grid icon here in the output window. So back to the graph. So after the main camera comes the setup group. So here I'm setting the context variables I was talking about earlier. We have some for the main focused position, so this is the center position of the particle effect, the node index, and a Boolean trigger for whenever a node is being triggered, and the intensity that I recorded from the audio volume. My little debug animation is still there, it doesn't hurt, and it's useful to check whether the syncing is spot on. Then comes the actual content. So the storyboard is also still connected but disabled. Once in a while I toggled it and to just check if the camera animation was on track. A procedural environment map is added with tweaked exposure and blur parameters. Then comes the single main point light. There's only one light in the scene and it's driven by the focus position variable and animated for the intensity. Then there's the fog and it was a little bit cumbersome to tweak because the color is changing, or the background color is changing. Then here's the opening scene, just uses some grid points with randomized positions and scale. I tweaked the random phase to avoid overlapping with the main ribbon. And speaking of the devil, here's how the main ribbons are built. We start with some radial points and map their color to a gradient. Then we emit them only once, or when the time is rewound, And then I use 5 forces to guide the particles through the complete demo. So we start with 2 force fields to keep the particles contained in the beginning and to prevent them from colliding with the ground. Then we have a turbulence force that drives the particles in the beginning. So on each node, the intensity is animated with a trigger anim. And then I offset the phase of the turbulence force with the node index. A new velocity force pushes them forward in every node. So they are doing like a little bit of motion responsively. And I will talk about the 5th force in a moment. It comes later. Finally, I pipe like these particles into a point trail and just draw them. I'm using the 50 or so points in the main system as an emitter into 2 secondary particle systems. One is the fairy dust in the beginning. First, I randomize the emitter rotation before replicating a spherical point set on each one. We map the sphere point's color to a gradient, and then slightly randomize the point's distances from the sphere. With 100,000 points, the particle system is nothing special. Note that I'm using the emit velocity factor that I mentioned earlier. Finally, we add some turbulence and directional forces to let the dust slowly drift down. Before drawing, I map the particle age to a color gradient to fade them out over time. At the end of the intro part, I slowly fade out the complete group, which will then be automatically discarded from rendering once the opacity reaches 0. Next comes the main particle system that is attracted to the landscape. Once again, we replicate the emit points, in this case with a set of radial points. This time the particle system has 100,000 points, which is the limit that my poor notebook can handle. We have that mushroom cloud torus force with the complicated name I'm not trying to pronounce again. I use the animated turbulence and field volume forces to shape the particles when I need to. The next 2 forces are special though. The first one is pushing the particles towards the signed distance field and colorizing them on collision. This switch, driven by the animated index, controls which scene is used. I nested the actual SDF stuff inside operators in a vain attempt to keep the graph clean. I've already talked about the landscape scene, but we can quickly take a look at the fractal part, which I think is pretty cool. Everything starts with that crazy city fractal by Zor, with its 10 lines of code. I had a very hard time understanding this little piece of shader code, but once it clicked, it was a very satisfying moment in my life. We used TiXL's shader graph system to cut out the space around the fractal, add a plane, and scale it down to the dimension of our storyboard. I used the push-pull operator to reduce some of its complexity. I struggled quite a bit to make the particles follow the SDF and used the visualize field distance operator in an attempt to understand how the distance field is shaped. It didn't help my understanding though, but it looks cool, so I thought I could show it anyway. With the move to SDF operator, I checked how a set of points would be driven by that field. Eventually, I decided to fudge it by adding some noise. So back to the main graph. The fifth force driving our point is the awkwardly named reconstructive force. It moves particles towards a point set. The scary looking stack of ops uses replicated grid points and some randomization to construct an abstract city made of points. But before using the set as targets, we randomly sample a color from a constant gradient. I recently added color lists and procedural gradients to TiXL, and this was the first use case I found to actually use them. The final setup is the most complicated part of the whole project, and it's completely fine if you zone out for the next minute or so. I wanted to have a very fine control over how the main urbans move through the world. After all, they also spawn all the other particles. I've tinkered quite a bit on this problem and eventually built the following setup. A set of control points is pushed through the scene. We connect the number of points to keep them in sync with the ribbon count. Over the progress of the animation, the radius and distribution of these radial points are carefully animated. I then move them to our distance field, damped their animation with this point simulation op, another awkward name right there, and finally again use a reconstructive force on the ribbon particle system to guide them. Yeah, that's seriously a lot, and I was really surprised how well it actually worked. So there you have it. That was seriously a lot. In the months I spent creating the project, I made roughly 300 commits to TiXL on GitHub. Most were only slightly related to Ashborn, and many were completely unrelated. It's probably the worst way to make a demo, but it's a great method to refine user interface details and implement new features. I didn't mention it before, but TiXL is fully open source and you can use it for free, including for commercial projects. If you are curious, you should definitely give TiXL a try. Visit our Discord server, link in the description, or just hit the subscribe button. Thanks for watching. See you next time.